Hey, what's up, app developers? My name is Hitesh Kohli and welcome to Developers Community. This will be the Kotlin Coroutines Part 2, and previously we have explored a lot about Kotlin Coroutines, the workings, everything that's working inside of Coroutine, the parts of it and how does it work, why do we need them, what is Kotlin Coroutine, everything. But now we will explore further on and explore some of the basics that you need. Let's get down to the basics of Kotlin Coroutines. Previously, we have seen that Kotlin coroutines can be divided into two parts. Coroutines part of it can be named as co plus routines. And I've already told you that co plus routines means concurrent routines. And these routines are basically different functions, as we've already explored before. Now, what are these functions? And I have told you about this one particular keyword called suspended. Now, what does it actually mean? Why or how do suspended functions actually work? Now, let's take an example. Here is a suspended function 1 and it keeps on working. It might need some kind of value from, let's say, function number 2. When the function number 2 gets finished, it will provide the value to suspended function and then it can continue. As you see, this function gets suspended from this point of time and works again when this function 2 gets finished. So that's how suspended function works. Basically, suspended functions mean the function will get suspended and free the thread so that the other functions can work on that thread, so that our UI or other features do not freeze in time. That's how suspended function works. One more thing that I want to introduce you to is that suspended functions are not normal functions. Any function cannot be a suspended function. They need to be called in some kind of coroutine scope. Tell them that this is a suspended function. Previously, we have explored about scopes, and I think so you would understand what a scope is if you know the basics of any kind of language, because scopes, local scope, application scope, these are the basics of any language. I hope you understand what are scopes. So any kind of suspended function requires a coroutine scope. Let's move forward and talk about exceptional handling in Kotlin coroutines. As you know that we are basically requesting some kind of response from a server using these frameworks, retrofit, kit, or HTTP, whatever you're using. And for example, the server returns null. What happens inside of the app is now the function gets a null value. In order to stop the app from crashing, because we're getting a null value in our response, we need to do some exceptional handling. We can do this in two ways. If you're using a launch function, which is the fire and forget function that I talked about, the coroutine does not wait for the response, but in async and await, the coroutine waits for the response to come along. So launch functions, we can use two methods here, a simple try and catch, and we can use some exception handlers. That's how we can do some exceptional handling in case of a launch. Now, what happens in the case of async and await? In this type of coroutine, we're basically waiting for the server to respond first and then we will continue. But in case of launch, it's just a fire and forget function. We can do this with the help of scopes. If we produce some kind of coroutine scope here, or a supervisor scope, with the help of coroutine scope and supervisor scope, if async and await returns null, it will not crash the application. But there's a thing about supervisor scope. If we use supervisor scope, it will return an empty value here. So that's how we do exceptional handling in case of server null response. Now, previously, we have talked about dispatchers in our video, and we have talked about dispatchers are different threads. With the help of dispatcher, we can switch our threads from IO to main to default. So dispatcher decides different threads, and IO main and default, we can use these two different things. Now, IO is basically used for our network calls. Main is used for updation of the UI. Default is used for CPU intensive tasks. We can easily switch between these threads with the help of a dispatcher. Now, there is one more thread that is called unconfined. We don't use it usually. Basically, what happens is suspended functions will execute on a given thread and will continue executing on whatever the thread is available if stopped. So what happens is unconfined is basically, for example, a function is executing on the main thread. Somehow the main thread gets stuck. Now this default thread is now free. The function will change automatically from main to default and continue executing. That's how unconfined works. I hope this made the suspended functions, the coroutine scope, all of the picture of the basics of coroutines very clear to you. Hopefully you enjoyed this video. Thank you for watching, and I'll catch you next time.